ever get tricked by your own eyes? Like walking home in the fog and you see something, some shadowy figure. Is it a dog? A shopping bag blowing in the wind? Our brains are constantly trying to figure these little mysteries out, trying to make sense of uncertainty.
It really is amazing how our brains are wired that way, to assess likelihood so quickly. We're always dealing with incomplete information, right?
It's like our brains are playing a guessing game all the time. And speaking of games, today we are taking a deep dive into a YouTube video by Artem Kirsanov. It's called The Key Equation Behind Probability.
This is a good one.
Oh, it's a great video. It really helps make sense of how probability shapes so much of our world, from those foggy encounters to, well, artificial intelligence.
And what I find interesting is how Kirsanov starts with those familiar examples like, dice rolls, coin flips.
Right, the classics.
Exactly. And then he takes us all the way to, well, AI, where probability gets even wilder.
Okay, so let's unpack that a bit. Kirsanov kicks things off talking about the two main ways to think about probability. First, there's frequentist probability, which I think feels pretty intuitive. Like, how often does something
Well, it's like keeping score.
Yeah, exactly. Like if you flip a coin 100 times and get heads 52 times, well, you could say the probability of getting heads is about 52%.
Exactly, just tallying things up over time. But, as Kirsanov points out, that only gets you so far. Like, imagine trying to predict tomorrow's weather just by looking at, how often it rained on this date historically.
Right. It's not like we can just replay tomorrow 100 times and see how often we get rain.
Right. Exactly. And that is where I think Bayesian probability really helps to fill in the gaps. Instead of just looking at those past frequencies, Bayesian probability is more like a degree of belief.
So instead of just saying 70% chance of rain tomorrow, it's more nuanced.
Exactly. It's factoring in not just the historical data, but also the most recent information, like what do the satellite images look like? What are the current atmospheric conditions? It's updating our belief about the likelihood of rain, you see.
So I'm already thinking like a Bayesian when I check the weather app, but then also look out the window to see how cloudy it is.
Exactly. You're combining different sources of information to update your own belief about getting rained on. And that, I think, lets us apply probability to so many more situations, including some that are, well, let's just say, mind-bending. We'll get there. But let's stick with the basics for now. Kirsanov also talks about this idea of a probability distribution, which can sound a bit intimidating.
It does sound a bit textbooky, doesn't it? But if I'm understanding this right, it's basically like a map of possibilities, yeah. It shows us how likely each outcome is.
That is a great way to put it. Think of a simple six-sided die. Each face has a probability of showing up when you roll it. And if it's a fair die, each face has an equal probability. We can visualize this as like a bar graph, Each bar is the face of the die and the height of that bar. That's the probability of that face landing upright.
Okay, I'm with you so far. But where do the multiple dimensions come in? Kirsanov mentioned something about AI image generation existing in a 10,000-dimensional space. I think I need a diagram for this one.
It is a tough one to picture, for sure. More than 3 dimensions, and our brains kind of go, nope. But the key is we can extend this idea of a probability distribution to things that are way more complex than dice. So